Okay, here we go. It's another Leetcode day. Longest valid parenthesis. This is hard, and my temptation is to skip it, but I'm going to give it a go. Give it a brief go. I have gotten jammed up on hards for like 2 hours before and just given up. In full disclosure, so see if I can do it a little faster than that. All right. Given a string containing just 2 characters left and right parenthesis, easy. Return the length of the longest valid well-formed parenthesis substring. Okay, I mean it's going to be substring at the end. I'll tell you that much. So it's easy. Why does it return int then? Oh, the length of the longest sub. So you don't even have to return the substring. You just have to return its length. Easy. Easy. Maybe not though. What did I do? No return. Yeah. Okay. Let's look at some other wrinkles. So there's just examples. That's the whole description. Okay, that's pretty easy. Well, it seems like a pretty straightforward stack problem. You push the left parens on, pop the right parens off. If you pop and there's not a valid left paren on the stack, then you abort. I think that's pretty much it. Doesn't seem like a hard to me, so there's probably some crap that I'm missing as far as the difficulty of this goes. Okay, so in this one, the longest valid is that, right? Okay, so it'd be push, pop, which is fine, push, pop, which is fine, and then this pop fails, and you step one back. Okay, so I feel like we're going to need like an int start equals 0, and I think we're going to need an end equals 0. We're going to need those to track the start and the end of where we're currently at. This is an efficiency problem in Java that I'm always a little bit weirded out by. Like, is it faster to do char at, or is it faster to convert it to a character right first? That's the hard part. So char r equal s dot to char array. How performance expensive is to char array? I don't think it's a lot. I think it's like a shallow copy because each string is a character array under the hood. But in this case, me doing a lot of char ats, I don't know if a char at costs more than an array reference. I don't think it does because it probably wraps to one under the hood, but I don't know. I'm just going to write a classic for loop again. At some point, I'll probably learn how to do all of these with maps, but probably shouldn't have named it R too. Okay, definitely going to use the built-in stack because I'm not a masochist, but how do you make the built-in stack again? Is it like this? I don't think it can hold primitives. Stack character. Stack equals new. Stack character. But why did I have to write my own stack in class if you can just use the built-in one? Blah, blah, blah. Well, you needed to learn, right? But never write your own one. The standard library will do. Where am I supposed to name it then? If this is the... What? Why does this think this is an invalid modifier? Oh, you can't call it public. Duh. Why'd you put the line there then, huh, Eclipse? Okay. You know, I use Eclipse for the syntax highlighting, and it doesn't even help me with that. Yeah. Sweet. Yeah, now I get all the wonderful utilities of stack. And this is probably not going to be like a 90th percentile solution. Right off the bat, since I'm using the built-in stack, I'm probably incurring more memory and other processing overhead. So, yeah, whatever. That's fine. I would rather use the standard library 99% of the time than get an extra 5 or 10% performance or whatever out of writing my own custom stack implementation. And plus, this is an interview and I'm timed, like 5 minutes less probably, but the few minutes I spend writing a stack is not going to be worth it. Okay. So I want to do if r of I equals left paren, I do some thingy-mabob. And then there's only two options, so I can just do an else. It's either a left paren or it's a right paren. You know what? Just to handle invalid inputs and to make myself look like hot shit to the interviewer, I'll put both arms in there. Because technically that's correct, right? You want to do nothing on invalid inputs. Okay. Oh, I'm already good to go for for the test case where the array is empty, right? It returns 0, so should I just go get credit for that? No, I'm gonna just keep going. Okay. So if it's a left paren you push, that's pretty simple. I don't even really have to push characters. I could just push like 0 or 1 or true or false or something. Whatever, it's fine. So I'll push left paren. And then here, let's see. So I want to peek the stack. If stack dot peek, man, technically I don't even have to see what I peeked. I just have to, because it's left and right paren, so would I gain a performance advantage from just peeking without even looking at what's in it? What does peek return? Okay. It would be like not null. Yeah, I mean, what is not null enough, I guess, right? Because what does stack peek return if the stack is empty? Throws empty stack exception if the stack. No, that's so confusing. Do I need to wrap this in a try catch? Oh, why did they do that? Why don't they just return null? Guys, because stack.pop does return null, I'm pretty sure. No, you get empty stack exception. That's fucking weird. Alright. This is a bad use of try catch. You can tell I come from the land of Rust. Okay, so I'll just try catch him on it, and then I'll just handle the stack empty down here. But if it's not, okay, so if it's not empty, then I'm done. I'm good. Whereas if it is empty, then I need to reset my start pointer. So I'm gonna do like so I'm gonna start and end is here. So every time you run into a new valid entry, you want to do end plus plus because you've moved up a spot. Okay, at the end, you want to return end minus start. Okay, and then when you pop something that's not valid, so the stack is empty and you've attempted to pop, then you want to move start up to, it's actually going to be the spot right after, right? But then you might have to handle the case where it's the very last item. It's going to be something like this. At this point, the stack is empty, so I don't need to do anything about it. I mean, end is going to move up anyway. That's fine. Yeah, this I'm going to need to rethink a little bit. But let's try it out. See how it does on some test cases. Write some more failing test cases, and then go from there. Okay. Woo! Past the empty case. Let's go. Alright. Okay. Oh, and we need to save the longest, right? Longest equals 0. So we're actually going to return longest if end minus start greater than longest. Longest equals end minus start. And we're actually just going to do that same thing here when we reset. Because, yeah, that works. Yeah, that's the item just before the pop failed, because I don't increment end till after, so that should be fine. Oops, forgot to copy this one. Okay, we got this one down, I got this one down. In case 1, so it's actually just, okay, so it's invalid on the first pop, which meant we should have incremented by 1. And then something went wrong in calculating the longest. Okay. So it should fail here, then start moves up to there. Can you guys actually see the test case? Yeah, you can see the test case. It fails here, then start moves up to there, and then it moves up one more spot and ends. Oh. Yeah. So what's going on here? Let's print on reset. Whoa, what did I just do? You know, I don't actually need the console here, so that's actually fine. Yeah, this is better. I can use the whole screen now. I'm going to use 100% of the brain. Okay, so it resets. Never? This one doesn't reset. But it attempted to execute a pop and failed. This one resets as it should. Oh, because it's an invalid left paren. It actually never has a matching right. Right. Okay, so you actually need to deal with leftovers on the stack. Oh, that sucks. That sucks. Shit. That's gonna be crap. Okay. I can think of a shitty hack to do here. I could push, instead of the character, I could push the index onto the stack. That's a smart idea. That's a big brain move. It's just left and right parens anyway. I don't care about being extensible. So I'm just going to push the index onto the stack. Right? And then if there are any left on the stack at the end, then I update the start accordingly. Right? Yeah, because that's the only situation. Alright, yeah, I think that's the only situation where it matters, when there is some left on the end. Huh. Alright, so if, is there a size? Yeah, there's a size. And I do want the last one, I want to say. I do want the last one. Then start equals stack dot pop. I think I want one higher. So in this case, the one that's left over on the stack would be 0. And I want to pop off that 0, and then yeah, I want to start at 1. Seems reasonable. This should handle that case. I will write some longer test cases for that leftovers scenario, though. I think that that's probably not going to fully cover it. Whoa! 3 passing test cases! Incredible! How do I add more again? Alright, I have to go back here. Okay. Let's do one where there's a bunch of right parens in front so it can just fail repeatedly, because that's a fun one. Then let's do, I slam my face on the keyboard. Then let's do that, nice. Let's do, there's a bunch of mismatched left parens. Let's do a couple right ones. And then let's do exactly 2 parens. That's a combo breaker right there. I don't know if that's, maybe that was one of the originals. All accepted? No fucking way, I already solved it. This is a Leetcode hard. This is how you get into the Googs. Okay. This is how you become a Googler. Yesterday, well, not yes, last week, it took me like an hour and a half to do a medium, so unless I got a lot smarter in the intervening time period. Okay, there has to be like a combo breaker here that I'm not seeing. I have to come up with a really smart test case by just slamming my keyboard. And oh man, here we go. Bunch of non-matching lefts at the end. Maybe that'll fuck me up. Let's try that. All passed. Well, fuck it. Let's submit and find out what I did wrong. Oh, I also submitted with the print line in there. Whoops. Okay, so we got this test. Oh, there are cases where, well, that's not fair. I didn't. Okay, now that I reread the question, I see that it was possible for there to be cases where there are no valid parentheses. But oh no. Okay, I just straight up got it wrong in this case. That's no, that's different. That's different. I thought this was the expected output was 0, not that my output was 0. Okay. Let's add this one back to the test cases and find out what makes it so wonky. Good thing I kept my print in there, because now I don't need to bother to put it back in there. Okay, so this one, mine never resets. Just interesting. So 1, 2, 3, 4, 5. This, it's actually perfectly valid. Oh, because there's a left paren remaining on the stack at the end, this fucker resets it. So I want to not do that. I want to not do that with the leftover left paren at the end. What is the indicator that I'm not supposed to do that? Is it that it exceeds the end? I want to say that that suffices. And I guess we could call it last pushed. This is me allocating more stuff, so it's probably going to ding my memory efficiency, but that's okay. So if last pushed is less than end, I want to do this. Otherwise, I skip it. Because if the last push parenthesis, well, alright, let's think. Let me actually consider the case where there are a bunch of these on the end that are supposed to be ignored. I think I actually might fail at that one as well, right? Right. And let's also consider the case where there are a bunch of similar ones on the end that must be ignored, but then also there's a valid, let's say, sequence at the end that is the longest. I think in this case I might actually be successful. Yeah. Okay. So, does this suffice? In these test cases, it does. There's also the case where there's a valid sequence on the end, and it is not terminal. Let's try that out. Out of test cases. Why don't you give me more test cases, Leetcode? You suck! Give me more test cases. I don't remember which one I replaced now. Is it this one? They all look the same! Just a bunch of parentheses. Okay, and then this case I would also fail at, I think. 2 valids in the front. And then yes, okay. So, does that successfully mitigate the problem? Not in this case, because in this case the last pop would be this guy who is indeed smaller than the end. So no, that does not solve the problem. So I want to clear the paren. I guess how do you appropriately know when you're not supposed to move up the end? What's the trick? So I've clearly advanced. So I've got a ton of parentheses on the stack. Do I go back to the first popped? No. In this situation, I've got a valid stack up to here, and then it continues to be valid all the way through to the end. But the answer is actually just these, because the bunch of extra lefts at the end don't count. So I want to rewind my end in this case. I actually want to rewind my end. And I think that this will solve all but case 3. I think that this will solve case 7 and 8. But case 3 will be the thorny one, because case 3 requires me to rewind the end as well. Empty stack exception. Oh, oops. Don't want to pop twice. Okay. So that'll solve... No, it actually doesn't even solve... Wait, it does solve case 3? Oh, okay, I moved it to 4. So it does not solve any of these. Yeah, these continue to be messed up, right? Okay, so if I change that to an equal, I would be able to solve case 7 and 8, but not 4. Really? I thought it would solve 7 and 8. Huh. No. Because these are, again, the problem isn't that start's in the wrong place. It's that end is actually in the wrong place. Uh-huh. Okay. Well, I could record the first one that I push as the stack is empty. That's possible. Yeah, I could do that. I could record the top of the stack. Technically, you can access, I think, the stack of 0, right? Isn't there just a get? Yeah, there's a, you're not supposed to do that, but it's better than opening up an extra variable for it. Yeah, okay. Right, so there's actually 2 cases. Stuff left over on the stack, and we're moving rightwards. We have to move the start up. Stuff left over on the stack, and we're moving rightwards. We've reached the end, and we have to move the end up. Those are the 2 cases. Okay. Interesting. Interesting. So, in this case, I had to move Cases where I got to the end and had to move the start up because there were right parens left on the end. Yeah, let's handle these two cases with some prints. Okay. Right parens left on the end. Move up start. Ah. No, that's different. Okay. Unclosed parens left on the end. I could iterate through the stack and see if any of them... Oh, yeah, I could do that. I could iterate through the stack and see if any of the ones that are pushed on there... Ah. Yeah. Okay, that's an idea. So I could loop through what's left in the stack, which you're not supposed to do, but whatever. I could loop through what's left in the stack, and I could see if any of them are smaller than that the last one here, the last valid pop. Do I want to keep track of the last valid pop in order to do that? I don't think so, because in this case, the last valid pop's all the way on here anyway, so... Or maybe I just subtract the number of things left on the stack from the answer? Does that suffice? Hmm. Let's think. In this case, the answer is 4. And there's all these guys left on the stack. And the answer that it's going to give me, in this case, the answer is 4. And the answer that it's going to give me is what? Well, let's see. It's going to pop all the way down. There's never an invalid pop, so this doesn't get triggered. It's going to push. So at the end, I'm going to have start at 0. I'm going to have end all the way over here. And I'm going to have these in the stack. Huh. Yeah, this could work. Let's try it. If end minus start minus stack.size is greater than longest. Why is this text white? Huh. Go figure. Okay, let's try that. Yeah. I think this will work for case 7 and 8. I'm not so sure about 4. No, it just breaks more cases. Output 13. It's not right. Yeah, okay. So what's wrong with that, really? All right, let's go through some debugging. Let's put start and stack left. All right, so that's going to be start and stack left is stack.size. See if I'm missing something conceptually here, because this seems like it makes sense. Maybe it's just that I'm not exceeding the longest because of the subtraction or something. Okay. Let's look at these weird cases. So, starts at 0, right? Ends at 5 at the end, right? And there's 1 left in the stack. So it should be 5 minus 0 minus 1 equals 4. Ah. This triggers at the end. Right. So I don't want to do that. Maybe it's just an else. But then I do want to. Maybe I don't. Maybe I don't want to override. Maybe that makes sense. Let's see. That should solve 7 and 8. We'll see about the others. Yeah, it solves 7 and 8. So broke 3, 4. Start 0 and 13, right? And then there were these two left in the stack that were invalid. Yeah. These cumulative invalids are going to mess with it. Definitely a problem. In fact, I can think of one more even better test case that deals with this. It's going to be one that has a valid but shorter sequence at the beginning, then pops an invalid. Yes. This one is like similar. Okay. So in both of these cases, I also want to subtract those 2 on the end that were a valid sequence but not part of the sequence that I was counting the size of. They're actually disconnected from that sequence because they're past that first opening paren. Yeah, that's difficult. That is very difficult. Well, maybe I do have to do what I was thinking of before, where I revert the end back to the location of the first opening paren. That seems to be viable. It's just that in the situations where you overwrite because of this, or the case where there's a leftover that's on the front rather than on the back, it's different. So like in this case, there's a leftover. No, I need a test case that has leftover front parens. Guess I'll recycle 8 for it. Okay, I need a leftover front paren. So let's do like an invalid, and then a valid, and then a valid, and then another valid. And let's have an extra open paren dangling in the front there. Am I still passing that one? It's this one, right? No? Which one? What did I put that? 3? 3, yeah. Okay. Yeah, so it's fine at rewinding these. Those are actually handled by my little subtraction trick. So it's bad at rewinding these. These ones where there's like a valid set on the end. Alright. So when the one at the end is not the longest, I basically need to rewind the end over there. There's probably a straightforward way to do that. But how? Maybe the trick is just not to move the end up until you actually have a valid terminating parenthesis. Maybe that's the more straightforward logic. So maybe I don't move the end up until I have a valid pop. Then I don't have to deal with all this weird subtraction stuff. It makes me kind of have to rethink all of this, but okay, let's try that out. Let's say I don't move the end up unless I have a valid pop. And if I don't have a valid pop, and I've reset the start, then I'll reset the end to the same place, and we'll start from scratch. Okay. Then I don't think leftovers need to be handled at all. So I'll comment that out entirely. But we'll see. Because this rewinding logic, I think, would get complicated pretty fast. What I really need to do is just not increment the end pointer in the first place. What did I do? I broke all my test cases. Oh, well, right, I still need this. If it finishes, it's not going to have a valid pop at the end, is it? Or is it? You know, it should have a valid pop at the end, shouldn't it? Oh, right, you have to move... No. You have to move the end up on a push as well, don't you? On a valid push. So this won't work, because it'll still move the end up on those valid pushes. Or, big brain idea, I move the end up by 2 on a valid pop and don't move it up on a push. That's basically the same thing. No. Why not, actually? That seems like it should be the same thing. Getting... Oh, yeah, why not? Probably because I didn't edit it in the place where I actually submitted it. Yeah. Hey, it got 1 right. Not bad. Start 0, end 20, stack left 0. That seems accurate. Oh, yeah, I still need this. It doesn't do this check until the end. Why did I keep removing that and then adding it back in? This will be like the 4th time. Okay. So we'll keep that. Yeah. That only triggers on an invalid pop, the resetting. Okay, cool. So this still solves 7 and 8. That rewinding issue, still not solved though, huh? Bummer. Okay, let me think about the logic of why that's not solved. This pop at the end. Yeah. Start 0. And then this pop at the end moved it up by 2 more. When it shouldn't have. Or at least it wasn't part of the same sequence. Likewise here. Okay, so this is still kind of the same thing. It was valid, but it wasn't part of the same sequence. There's this opening left paren that wasn't terminated, so it's going to get discarded at the end. So it looks like no matter what, I'm going to have to deal with some stack residue. I mean, alright. So, I now increment twice on a pop. I'm either not supposed to do that when it's not part of the same sequence, but there's no way to know that in advance, because all of these could easily terminate ultimately. You know, they could ultimately all close like that. You wouldn't know if they all closed or not until you got to the end. Right, so it would be valid if they all closed, but then invalid if they didn't all close. So let's do a test case for all but the very last one closes. Okay. So valid if they all close, otherwise I have to rewind. If there's something left on the stack, then I want to rewind the end. Okay, let's try that in a really straightforward way, and maybe that's the solution itself. Maybe Maybe I'm just have to set end equal to the last thing on the stack, the first thing on the stack, because that handles the rewind pretty elegantly. My intuition is that that breaks a lot of the other test cases. Well, it does handle the rewind, so goody on me there. But it does break some of these other ones. Start 0, end 18, and then it rewound to here. Ah, here we have a giant valid sequence that should have been the longest. But instead, it went and rewound to that other one. Because there was never a pop here, it never reset the sequence. So, oh, this is a really complicated case. Because there were a bunch of pushes that were valid, a bunch of pops that were valid. There was never an invalid pop. But at the end, there is a left paren, left orphaned. That shouldn't have counted. So realistically, I should have just not counted these at the beginning. But since that left paren is left on there, it doesn't know what to do with it now. And these are similar to the case where there's a start parenthesis that's left orphaned. So it's the same mistake as, say, that probably should run into the same issue. No, that one's fine. Wait, which one did I? Oh, yeah, that should run into the same issue. So in this case, I should move the start up instead. So in both of these failing cases, the problem was that I didn't move up the start. Eh? This one just passed. Wasn't it the one that just failed a moment ago? I think I accidentally overwrote the wrong test case. Just replace test case 1 with this one. I have so many test cases now. This is, this is overkill. I want more, though. I want to be able to have all of these. It's very obnoxious that I'm limited Leetcode. I bet if I pay for premium, it'll open up all of them. Yes, okay. Yeah, so these are the same prompts. So in this case, you're supposed to reset to start first. And now I'm pretty much back in the same boat as I was 10 minutes ago, so this little venture did not work out. But all right, so there's that extra condition here that I'm missing. It's that there's something left on the stack, and then you have to determine whether or not it's to the left of the valid sequence or to the right of the valid sequence. And then depending on if it's to the left or to the right of the valid sequence, you either update the start or the end. That is the rub. Okay, so if the stack size is bigger than 0, all right, so all right, int last pushed equals stack.peak. I'll just won't pop it for no reason to pop it anyway. And then int first pushed equals stack.get 0, violate stack rule there, whatever. Okay, so it's something to do with if the first pushed is beyond the end of the sequence, then you update the end. If the last pushed is before the start of the sequence, then you update the start. It's never both. It's either you have a bunch of left parens on the end that are unmatched, like this. No. Yeah, a bunch of left parens on the end that are unmatched, like this, because this is the valid sequence at the beginning, and then all these left parens are unmatched. Or you have a bunch of, well, in this case, one left paren that's unmatched at the beginning, then you have to update the start. So end equals first pushed. Okay. Well, maybe a simple check is if first pushed is before start. And then otherwise start equals last pushed. Maybe this suffices. If it's only one of those two cases, I actually only need to get one. I don't need to get both. This is a tough copy. Okay. Let's go! I broke some more, but I solved some others. Okay, so I solved this one. Yeah. I solved this one. This one I didn't like. Outputs 2. That's not right. It output this one at the end, but it's supposed to have outputted this sequence that came earlier. Okay. And then there's this guy. This guy. Yeah. Oh, I put 0 here, so here I think it moved the end up. Start 0 and 0. Its first push should be left and start. No. Shouldn't be. So would have updated the start instead, which in this case is wrong. Right. So this would be the first pushed. It's not less than the start. I think I flipped these. Flipped my conditions. Let's write a print instead. Last paren is beyond sequence start. No, in this case it's before sequence start. And then last is after longest sequence start. So far, this solution has proven to be very easy at first, and then very complicated as you get into the edge cases, as is traditional of any Leetcode hard. Okay, so after longest sequence start, is that true? Yes. No, it's before. It's before. It's less than start. It's, yeah, it should be before. First pushed is this guy, and it's before the start. Is it just a lack of an equals there, I think? Yeah, just a lack of an equals there. Yep. Okay. Last is before the longest sequence start. Right. Start 0 and 4. Stack left 1, the remaining left paren here. So it's before the longest sequence start. Start becomes last pushed, which is this guy. And then somehow I get the right answer there. Actually, doesn't seem correct, but anyway, okay. Is after the longest sequence start. So this is the most complicated one, I think, because the longest sequence is this, that, yeah, something like that, I want to say. And in this case, the longest is the last is actually before the longest sequence starts. Yeah, because the other one started down there. Bugger. Maybe I need to rethink the way that I determine what the longest is. Maybe I need to rethink doing it at the end. Maybe I should do it on every valid pop. Because if I was to do it on every valid pop, and also identify the first one in that sequence, then that would be fine, I think. I think that would be fine. I mean, I'm storing the indices anyway, so I should be able to do that. When I execute a valid pop, the new longest one can be determined, I think. Well, let's try it out. I mean, it can't be worse than this incredibly convoluted solution, so, how bad could it be? Alright, so when I execute a valid pop, rather than moving up the end pointer, in fact, I probably pulled this off without having start and end pointers at all. When I execute a valid pop, no, I still need the start. Or do I? No. So the thing that I just popped off is the start. The thing that I'm currently on is the end. So if I'm popped, I've got a right parenthesis. That index is the current valid endpoint. I've got the left parenthesis that matches it. That is the last valid start point. If that span, try it out. So if pop minus, no, this is where I'm at, so it would be I minus pop is greater than longest. Longest equals I minus pop. This way, I solve this complicated one because it doesn't care about the invalids at all. In fact, it would do nothing on invalids. Crikey, this is something. I'm going to have to print this because this is too complicated. New longest between well, let's do start to end syntax. Easier to read. And I equals longest. Okay. And I won't copy that print line. I don't need it. Okay, this is a lot. So let's delete all of that stuff. I don't even need the start and the end stuff. So hopefully I copy and pasted that correctly. Okay. So just off by 1, it looks like. Yeah, looks like just off by 1. Between that's interesting. That it's, what is the longest sequence here? I need one that's easier. All right, so it's between, there's nothing on push, nothing on push, nothing on push. Then here it's between these two, between 2 and 3. Oh, oops. Did I do it backwards? No, I didn't do it backwards. What? I don't get it. 3 minus 2 is not 0. Oh, I forgot to. I did this before instead of after. Yeah, just inaccurate. Print. That's gonna mess with my head unless I fix it though. Okay. Try that again. So 3. 2 minus 3 minus 2 is 1. Between 1 and 4. Yeah, 1 and 4. Yeah, that's correct. So it's just off by 1. Yeah, this is just off by 1. It's the nature of using the indices for your length. Just have to add 1 to get the length from the indices. Okay, so solves every case but 3. Damn you 3, you thorny bitch! Okay. The expected is 20. Why 20? Well, I solved all the other ones, so I like the solution so far. It's a hell of a lot shorter. New longest between 1 and 2. Okay, it's off by 4. It's like it's missed a whole bunch of sets of matching parens. Is it because this sequence counts too? Yeah! Fuck! That's complicated. So that sequence counts too. So my whole matching the left and right shit doesn't work because there was an earlier valid sequence that counted. Uh-huh. 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 Okay, so what I need to do then is keep like a cumulative tally that I don't reset unless I do it here. Right? Yeah. Yeah. Okay. I'm probably going to regret deleting all of that, but there's always the undo key, so. Int longest, int, what do I want to call it? Like valid pre-sequences or something? Yeah, so like if there's a pre-sequence like this that's 4 parens that comes completely before this, then I want to add its length to the rest. So, okay, so if you've popped successfully and the stack is now empty, then you want to add it to the valid pre-sequences. So then valid pre-sequences plus equals the length of this guy. It's I minus pop plus 1. So you want to add that to the valid pre-sequences. And then all of this stuff, I had a typo in there, I was missing the plus 1. All of this stuff must account for the valid pre-sequences, which get reset if you run into an invalid pop, but don't get reset if you run into an invalid pop that's after. This still isn't going to work. If you run into an invalid pop that's after the sequence, then it's not going to work. Man, there are so many edge cases here for what's ostensibly a very simple problem. Yeah, I was like 99% of the way there in 5 minutes, and then I completely broke it. Yeah. Yeah. Yeah, that's not going to work because it needs to be, not only is the stack empty, but then another sequence is started after it. Well, I didn't do the check, so this is buggy, but we'll see. Alright, if stack dot size is 0, then I want to update the valid pre-sequences. Forgot to do that. Okay. Leetcode hard. So hard. We're back to the same shitty broken test cases, but now I'm off by slightly less. Okay, so I got that for sequence, and then I added onto it, and all that good shit. And then this one's busted too, because of something. Okay, so here I got... What's the problem with it? So it's... The last outermost one is probably... Is this a valid pairing? I don't even remember if this is a valid pairing. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It's a valid pairing with an extra left paren. Yeah, okay, so it has one extra left paren, so it's actually valid up through here. Oh, that's why it's fucked. There's a valid pre-sequence, then an invalid left paren. That's even worse, because I have to discard the valid pre-sequence as soon as I hit an invalid left paren. Obviously can't tell if there's an invalid left paren until I get to the end. I'm beginning to think the better solution might have been not to use the stack and to just read from the left and the right and just go inwards, but I don't think that would work either on account of these like nested sequences being the main and most difficult problem here. So it's the fact that that invalid left paren is there and that I can't identify that on a push. I'm back to that situation where I have to rewind. Or in this case, I'm not really rewinding, I'm just dropping the valid sequences because I didn't find a thing. I mean, it might suffice to just subtract the valid pre-sequences from the longest if I've gotten to the end and there's still some stuff left on the stack. However, if that stuff left on the stack comes way before the left paren, then that's not going to suffice. Like if there's a valid pre-sequence, an invalid left paren, then another valid pre-sequence, and then a valid sequence, and then the end, then I want to subtract just the first valid pre-sequence, but not the second one. The second one follows the invalid paren, and I won't be able to do that because it didn't accommodate for that. So what I do want to subtract is everything that comes before the first invalid paren. Yeah. Yeah. So I think I actually had a better solution earlier with the start and the end stuff. This one that just tries to match the left and the right it's not really going to be possible ultimately. Have to match those right and lefts too hard. All right, okay. Back to the back to this guy. Trying to figure out how to get this guy to work. So it was whether or not the last was before or after the longest sequence start, and then we had to do some resetting. I think I'll copy and paste this and run it again and get back to the logic that this was in. It's a shame that this one's just so long. I think I'm going on an hour on this again. It's not a good look for me. I was almost a Googler. I almost solved it in 5 minutes. Now I'll be lucky to work at Oracle. Sorry, Oracle. If I ever work for you, I'm sure you're a great company. Yeah, so it's when invalid parentheses interrupt the sequence, when they're actually in the middle, kind of, that this one can't handle, because in this case the invalid one's right there. And you don't know that it's invalid till you get to the very end. But it is actually before the longest sequence starts. It's just this can't see that, so I need something that reads that it's before. I need to figure out that it's before somehow. And let's see, I'm sure this is in the same boat. I have one valid pair at the end. Start 0, end 4, stack left 24. That's just weird. What? Oh, because I switched it to only updating the end on a valid pop. This was one that's supposed to update the start pointer. Oh, and this one has to update the end pointer too, because they're actually both wrong. My earlier solution was better. It's like the very first one I did seemed to be the champion. Everything I've done since then has made it worse. Should I just rewind all the way back to that? Yeah. How far back is that? Yeah, this whole like always updating the endpointer one, that was slick. Not caring about what you pop, that was slick. I think that was the way to go. I might use this though. This was nice. Yeah. Okay. The OG of OGs. Okay, so it's those weird stack size cases. I want this, the meat of it. Don't want the rest of it. And then this is probably not going to work, just using the stack size. Yeah, I don't think that was ever really viable. Alright, let's get back into that logical framework and see if we can crack this bad boy. Crack this nut wide open. I still feel like it's something I'm missing in the condition that's just so simple. It's just gotta be so simple. I still have end incrementing here. It's gotta just be dead simple. Alright, these are all the basic cases. And then I've basically replaced all my test cases with these funky edge ones. Funny. Okay, so the last thing is before the longest sequence starts. That's correct. And then I want to update the start to 1 greater. I believe that that will solve that edge case. That's just that being off by 1. Whoops. I just tried to save this web page. Okay. No, that didn't fix it. Oh, I still have to do this. Okay. One test case left. The hardest one of all. It's this invalid left paren. This invalid left paren, and it thinks that it's after the longest sequence starts, and it is correct that it is after the start of the sequence, but it is not after the longest. The longest is actually the shit that happens after. So it's just, again, this condition that I seem to be too smooth-brained to figure out. That's just a more universal application. It's not enough to say that it's before the start. There needs to be something more. Do we rewind the start to there or not? Because in this case, it went here because it's not after the start. Yeah. I guess there's kind of like a supplementary condition. Like, okay, so if that invalid left parenthesis comes before you start, yeah, then we rewind to that point. Unless the stuff that comes after it is longer than the stuff that came before. Right, because, I mean, you're basically, okay, so you're creating subsequences of parentheses. And then you're trying to find the longest sequence of subsequences. If I had thought of this originally, I probably could have cracked the case by now. It's the longest valid sequence of subsequences of valid parentheses that aren't separated by an invalid one in the midst of them. And if I was starting over on this, that's probably what I would try to do. I would try to probably make like an array of stacks or something and combine them together as long as the indices line up. That's probably the best way to go at this, is to find all the valid stacks of parentheses in there. That's professional streaming right there. Okay. So I could still probably hack the solution to make it work though. It's about resetting to before the longest valid sequence versus resetting to some arbitrary point where you started. Yeah. Yeah, you're almost like once you... Maybe I should just do this just because it'd be more interesting. Find all the valid stacks and then combine them together. That might be amusing. Should I do that? Should I start over? I'm gonna try. Let's try it out. I'm sure it won't take me as long as it'll take me to hack this stupid solution together. So I'll call this old and start over here. Okay, so it's actually going to be a list of stacks. That's some weird syntax right there. I'm not even sure if you're allowed to do that, but I'm pretty sure you are. Okay, so I always start with a fresh stack. I start with an end and a longest and all that good stuff. Okay, so if it's a valid paren, I push it. Cool. If it's a right paren, I pop it. Do I really need to keep them on the... No, I don't really think I need to keep the stacks themselves. I really just care about where the sequence starts and ends. So I actually have an array of starts and ends, and that suffices. So I can call it in starts, seek starts. Well, boy, I don't want an array because I don't want to have to deal with resizing it. So let's do an array list. Integer. I could combine these into a single list too by using a struct, which again Java doesn't have if you watched my last video. So good stuff. Let's do it. Let's do it. Let's make it even weirder. Public class stack info. I think I have to make it static for it to work in Leetcode. Okay, so now I'm going to create a list of all of the valid stacks, and they're just store their start and end points, since that's all I care about, relative to the original array. So now as I'm moving through, if I encounter a... Get this out of my view! If I encounter a valid left paren, I push it onto the stack. If I encounter a valid right paren, I pop. If I encounter an invalid, then that is the end of that stack sequence. I need to add a new end of sequence. And final length. Okay, so then I don't even really need a longest actually. It's just length. It's the length of each subsequence. Int length equals end minus start. Okay. Final length plus length. Okay, and then I want to save it to my thing, and then restart at the next one. Hey. End of sequence, starting at yeah, I want to do that basically. Yeah. And then the length is actually the current index minus start. We don't even really need an end here. We do need to keep track of the start since it changes as you go through different stacks. So the end of the stack is the index where you found the invalid pop. It's actually that one before that. The start of it is where you began. It should be I plus 1. I believe. Yeah, you're going to move up. That'll accommodate for the pop being 1 before. Okay. So then the end, which you don't need. All right, info dot add new stack info with its current start. Constructor. Dealing with structs in Java is so obnoxious. It's just so much extra effort. All right, let's see if this is good. Just with print lines. And then at this point the stack's empty, so I just actually can recycle the same one. I don't have to use a new one. And then I don't need end. Look how much shorter it is. So much room for activities. Of course, it's going to get them all wrong since I just returned 0 as a placeholder, but let's see. Oh, I need this static class in there. Okay. And if there are no invalid pops, then I also need to add one at the end for that. Do I need to do it only if the stack is size 0? Yeah, I think so, because otherwise it's not a valid stack. And then this would just be like, well, if it got to the end without running into an invalid pop, then it's always r.length. There's one of these too. End of valid sequence. So many extra variables for my print statement. And so many extra lines, too. But hey, it helps me keep my train of thought, which I haven't been doing great at so far, so. Okay, here we go. Let's see. End of valid, okay, that's correct. Here, it didn't print anything? That's weird. I mean, there was an invalid. Right. So these, the left paren, the sequences that finish invalid. Need to figure out what to do with those. I think in this case, it is actually acceptable to just subtract the stack's size. Let's add that to the printout. See if that's accurate. I believe it is, though, because in that case, we're good. Alright, so in this case, end of invalid sequence starts at 0, ends at 5, and its final length is 4, which is correct because there was 1 left over. End of valid sequence starting at 0, ending at 20, final length 20, that's correct. Okay, here, the expected answer is 14. Um, hmm. Ah. I actually also want to end sequences when I've finished the final pop too, right? Yeah. So if there's nothing left, it's starting to look a lot like the other solutions. If the stack is empty when I pop, that's also the end of a sequence. Right. And then we just move up to the next. Okay. And then I'll kind of label these with a box so that they stand out from those two. Gets the whole try-catch can be replaced. That seems like a modest change, though. It was this one. Okay, that's incorrect. Good. Not good. Huh. Ah, yeah, here you don't need to accommodate for that. So you just want to add one more there. Yeah. Try that again. Because in this case, the last thing that you popped is valid, so you want to include it. Okay. I am a little confused by this. Is this just that floating right paren? Yeah, that floating right paren, which is not a valid sequence. Or is it? Actually, I don't know what a single floating right paren would be. I think it would just be 0. Yeah, a single right paren is length 0. Those don't count. Okay, so it's a valid sequence that's 20 long and a single floating right paren. That's correct. Here we have a 0 long. Well, no, that doesn't end the sequence until the end. So we have an invalid sequence. This left paren was omitted, so the final length was 4. That's correct. Okay, here we have two valid sequences, a 4 and then a 16. And then it looks like a floating right paren at the end, which is fine. Okay, and I'm ultimately going to add those two together. Here we have a valid 4. And then this one is an invalid sequence type. Right. So the answer will actually be this one because it's the longest. Okay. Here we have a valid 2, then an invalid right paren, then we have a valid size 4, and then we have a bad left paren, and a valid length 2. Oh, it is actually a valid length 2, isn't it? This is the valid length of it. The rest of it is all incorrect. Right. Okay. So it looks like I've got my framework set up. At this point, I have all my stack infos. Now it's a matter of merging them back together again. Okay. Okay, I'll keep the print statements for now. What am I on here? What is this? An hour 30. Fuck me. I suck at this. I'm almost there, though. I'm not going to say I promise, but I think I'm almost there. All right, for I in info. How do you do the fancy for loop again? Is it I and for stack info I in info. Is that how you do it? Or is it this thing? It's this thing? Yeah, it's that thing. Okay. Alright, so I'm looping through them. I'm actually going to need a regular for loop here because I think I'll need access to its indices. Size. Okay. And then I want to stop. So if info, if I plus 1 is less than info dot size, I want to check if the stack. So I'll need a longest here. This is where I'm actually determining the longest. I can restore this now. Okay. So I want to see if these line up exactly. I want to see if the end of the last valid stack is the index just before the start of the next valid stack. In that case, I can combine their lengths together. If not, I can't. So, can combine valid stack sequences. Can combine valid sequences if end equals start minus 1 of next sequence. If end of seek equals start minus 1 of next. Yeah, that's basically. So if info dot get I dot end plus 1 equals info dot get I plus 1 dot start. Then I may combine them. Then I can combine them. And I can do this indefinitely for any number of sequences that are sequential like that. So the question is, how do I continue to do that for multiples here? How do I combine multiple valid sequences that are back to back like that? So in this case, I have like my 4 valid, and then my big valid, and then an empty. So I want to combine those two together. But then there could be yet another valid and another valid. Yeah, there aren't. Yeah, like this one has 3 valid sequences back to back. They all need to be combined. Yeah. Okay, so 3 valid sequences back to back that need to be combined. Do I want to save the last endpoint and continue from there? I don't think that'll work. It could, but I don't think it will. Do I want to save the last start point? I don't think so. Let's see. Combine valid sequence is a problem in and of itself, really. So okay, I can't deal with having this asinine name anymore. I should rename it Stack Infos or something. This is bad. Okay. I guess I could do a nested loop, right, through the rest of them and just do an early abort. I don't think it'll cost me a lot of performance, and it's going to be a lot easier than trying to hack together the logical solution to this. So I think that's what I'm going to do. Okay. So for int k equals 0, k equals I, k is less than stack infos dot size k plus plus, and then it's similar to this. Okay, so k equals I to the less than, and then we combine them together. Combine them together, we do that indefinitely. Combined length equals, yeah, I really should have saved the length. Info.end minus info.start. Okay, and then so as I loop through the rest of them, if they're valid, I'm going to combine them, otherwise I'll break out of the loop early. So if it's a valid sequence, that means that the end is good to go. So I'm going to go with stack info. It's going to be current and next. This is kind of linked list-like in its iteration, actually. All right, so I'll do a current and a next so that I don't have to have this complicated naming here. So if the current's end is also the next's start, then I want to add the length of the next one, which, oh man. Yes. Okay. So I'm getting its length. Then I'm getting the length by combining it with the rest. I'm actually just going to use combined length for everything. Then, okay, so I'm getting its length. Then I am combining it with the rest of the sequence. I can actually speed this up a bit to do skip k many iterations in outer loop. This will increase the performance a bit because once I've combined valid sequences, I don't need to visit them again. I can skip them because it'll always be shorter. If sequence 1 plus 2 plus 3 has a certain length, then sequence 2 plus 3 is always going to be that length or shorter. So I can skip sequence 2 and 3. So actually, I can do this pretty easily. I can say I plus plus here. That will skip them in the next generation. Okay, and then finally, if combined length is greater than longest, longest equals combined length greater than longest. So I already did that. Okay. Don't need this. Okay, so sequence I has length that's its original length, right? And then we've got sequence I combines with plus k for total length. This is going to be such an inefficient solution. I can guarantee that I'm going to be like the bottom 1th percentile here. But as long as I finish it at this point, I'll be happy, because this is, well, like 90% of this is print statements right now. So that's okay, I guess. All right. I mean, I'm sure there's a bug in here somewhere, but let's try it out. Okay, looks like there's some off by 1 going on, but that's not a big deal. So let's see. Sequence 0 has length 19. Okay, so I need to save valids and invalids differently. Now, when I save an invalid, I need to save start plus 1. Start plus 1. I'm already going to tell that. Really, I should have just been saving the length. Yeah. When I save an invalid, because that means, oh, okay. This means that there was a leftover left paren, because there's leftover stuff in the stack. This means that there weren't enough left parens. So then, yes, no, I popped a right without a valid left. So if I popped a right without a valid left, does it start? Am I getting it start and end place correctly? I should update this print to reflect what it actually is. Okay, if I pop a right paren, that's not valid. No, this won't work. No, I need to keep the actual start and end points, or I'll mess with the thing. What I probably need to do is designate whether it's valid or not. And yeah. Yeah, fuck it. I already have the length calculated everywhere. I'm going to calculate it here. Okay. So then, true, false, true, false. This tells me that the sequence, because I have some longer invalid ones here. Starting at 7, ending at 16. No. I should only save valid sequences. I shouldn't save invalid sequences. So I should save the start of its valid point, and I should save the end of its valid point. So, in this case here, when I said invalid sequence starting at 7, I shouldn't have done that. What I should have done was said invalid sequence starting at, and then I should have gotten its actual start. In this case, kind of back to what I was doing before, which is that I have to find the last valid left paren on there, which in this case was the last one pushed onto the stack. So last valid paren. equals, man, how do I always end up back at this? There's no way to get out of this problem. Man. Yeah. Even finding the last subsequence. But at least this solves some of the, I think, solves some of the other problems I had. So it'll be stack.peak. Shouldn't have to subtract the stack size anymore. Starting at last, whoa. I think it's +1. I think it's going to be +1. I'll keep that leftover printout there. And then in the case of an invalid right pop, I think we're good to go, actually. I think I just maybe want to scoot. So, invalid sequence, it ends at 1. No, that's fine. Yeah, that's fine. And then the next start moves up. Yeah, because I'm using I instead of the end. Yeah, I think that'll do the trick. All right. Sequence 0 has length 1. Okay. So what happened here? I did these 3 combine because it should have been. It should have just been this length 4 one. Yeah, it accidentally combined with this length 7 one. Ah. It actually combined sequence 0 with sequence 1, which it shouldn't have. But this invalid sequence does. Oh, I guess length 0 sequences shouldn't save at all. Yeah, length 0 sequences shouldn't save at all. Invalid pops. If it was length 0. Okay, so this stuff only happens if the stack is non-empty. But I still feel like I might be saving the wrong start and endpoint for this stack here. I feel like I might need to save. I mean, technically, this invalid sequence here is correct. It starts at 2 and it ends at 2. So that seems correct, but something tells me that I shouldn't be saving it at all, which is what I did there. But something tells me that I also should be doing that for the longer non-valid sequences as well. Okay, so sequence 0 has length 19. Yeah, see the way that I determine length differently, depending on whether it's valid or invalid, makes me think that maybe it's messed up. Because I shouldn't have to do that. I should just, yeah. It's the valid sequences between 0 and 19. That's correct for the indices, right? I mean, it's between indices 0 and 19. I just have to add 1 to account for the fact that they're indices. The invalid sequence starting and stopping at 20 is correct too, and it is also correct that it is length 0. Okay, the sequence 0 has length 19. is technically correct, but I need to add 1 to it. Okay. Sequence 0 has length 5. Here is incorrect. I need to subtract 1 from it, because this is the thing on the end here, right? Last valid paren. Okay, so it starts at 1, which is correct, and it ends at 5, which is correct. So its final length is 4. Oh, I forgot to change the start when I save the stack. Right. So that should fix that. Whoops. Didn't actually change it here. Where it actually matters. Okay, last friend, so change it right there, and let's see. So for this one, it's gonna be, oh, we got some going green, so we're getting somewhere. I just need to fix this. The valid sequences being the wrong length, but showing the right indexes. Likewise for this. So I got this sequence, it's valid, it's length 4, but I've gotten off by 1 because if you just subtract the indices, you're getting the wrong length there. Sequence 0 combines with 0 for total length 3. Okay, so that's wrong. I gotta start 1 ahead. Wait, no. I don't want this. Yeah, I don't want that. Because I'm gonna do that in the first generation of the for loop anyway. And rather than starting 1 ahead, which I feel like is more confusing, I would rather combine them together. So I've got that instead. That should be closer, but still off by 1. Total length 0. What? Oh, no, that was correct. Because I forgot, I take the next one. Yeah. It's actually combining with, the print's wrong. It combines with k plus 1. Because I combine with next. I add next's length, not previous's length. Or current's length. Right. Okay, so the print was wrong. The logic was sound. So yeah, I'm combining k plus 1. Yeah, next. Next is k plus 1. All right. All right, so sequence 0 is length 3. Sequence 0 combines with, I didn't actually change it here. I don't really know why I need to print this bad at this point, but it's fine. Okay, that's length 3, then it combines with 1 for a total length 3. That's weird. All right, so it's valid, and the length is wrong. What? Huh? Current and the next. Why would it? Oh, I should print after. Yeah. There we go. Well, that's badly formatted, but that's fine. Okay, so secant 0 is length 3, then it combines with 1. Okay, so it shouldn't combine with this. Why is this even considered valid, starting at 20, ending at 20? Because it's a right paren. Yeah, it's a right paren. It shouldn't be considered valid. That comes from here, so that's the stack is... Oh, is it just that it's empty? Yeah. Why do I even need that? That's weird. Wait. If there is an empty stack at the end, then why am I adding this? That's an empty space. That's just literally nothing being added on the end there. Oh, is that for the... Yeah, that was to handle a okay, but I handled that up here, so I don't think I need this anymore. I don't think I need this anymore. Do another fresh copy pasta. Because I have handled size 0 pop cases within the pop loop now. All of this to get O of n performance! Okay, so yes, now there's a single valid sequence. Single valid sequence, so now we just gotta deal with the length issue. What can I do to get the length to be good to go? Should I save the wrong index? I can't save the wrong index. I can't do that. That would mess it up. This actually saves the true start. Well, let's find one of these. This guy, blocked invalid. Invalid sequence starting at 2, ending at 2, final length. So that's this bust paren. This shouldn't be saved, actually. Right, so this starting at 0, ending at 1, final length 2, that was this guy. Did I not copy that logic? No, I did. Oh. Got it backwards. It fails now, does it? That was the one that was just passing, I'm pretty sure. Let's print something here. I can't do print line. Okay. Found invalid single R. Pen at we'll just like print that so that we know that it's there in our little printout here. Okay, so found okay, so there's a valid sequence of 2, then a valid sequence of 5. That sequence is these 2. That's not 5. That's 4. That's 4 long. Why am I getting the length wrong? What? Starting at 2. No. Oh, okay. So I need to restart the start. So it's not do nothing. I actually need to move the start pointer up, or the start pointer becomes invalid. So if I find a right paren, I just advanced the start pointer without saving it. That should fix that to an extent. It would help if I edited the thing that actually runs it. Okay. So I advanced the start pointer by 1. That gives me the should be the right answer here. Yes. Okay. So yeah, now I just have that in regular off by 1 error. Okay. All right. So for valid sequences, I'm always getting an off by 1 error because when I do the subtraction, I'm assuming that they are invalid. How does that work here? Okay. So this invalid sequence that gets saved starts at 1, ends at 0, 1, 2, 3, 4. Right? Yeah. And it has a length of, where's that printout here? It has a length of, well, what am I saving for the end? I'm saving the array length for the end. I should be saving array.length minus 1. That's the last index. I'm not saving the indices correctly. That would probably have caused other issues down the line with other test cases that I simply didn't catch. Because this is a length 5 array. The last index is actually 4. That's my convention for saving it in other cases. That means that I can now, when I'm getting the length here, I can just add 1 to get the actual length. I believe that is correct. Okay. That will fix some of it. It might fix all of it. That might be good to go. Wow. Okay, I'm coming up on 2 hours now. I think I'm just going to risk a submission with all the print statements and everything and see how. Fuck! Oh, so close. 174 test cases passed. Okay, it found an invalid singleton. And then it found the end of an invalid sequence. What? Is this whole thing invalid? No, expected 22. Alright. Try it out. Okay. Invalid sequence starting at 25, ending at 24. How did it move up? Okay, it found an invalid. Single paren at 0. So it did this. And then it found an invalid at the end, which is the last valid left paren. In this case, the last valid left paren is this one that I popped on the end here. Oh no. What a special edge case. Oh, this is fucked. This is so fucked. This is a masochistic, sadistic question, if I've ever seen one. Okay. I mean, it should have terminated. So when it got to the end of if it was a valid sequence, when it got to the end of popping them, it should have terminated. So why didn't it? What's the valid subsequence that's contained within? It's this, right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this is the valid subsequence in there. Ah, and it doesn't empty out because there's still one paren left to pop that didn't get popped at the end. So it's a case where there's a leftover paren, but also there are other leftover parens that got popped after it. So it's like left paren, the sequence, and then some more left parens. So then you actually have the yeah, you actually have the left parens being before the sequence. So saving it becomes complicated because of that. Okay. So you have a left paren, a sequence that's valid, and then some more dangling left parens that never get closed. Oh, 2 hours is starting to get boring. Okay. Definitely not going to get that Google job. Although, maybe if I submitted that first one and then just moved on, that would have been the best from the point of view of the interview. Since I obviously can't figure out that case and it's coming back to bite me again. It's when is it before, when is it after, when do you know? Okay, so it's that the last left paren was before the sequence. So I could like go through the stack and see if there's a left paren that comes before the sequence and then grab that one. Because what if it was like this? What if it was, you could have any arbitrary number of non-matching left parens before the valid sequence. Right? So I actually have to find kind of I have to find the first left paren that's before. Kind of. I think. So is stack.pop, and then while stack does, what is it? Is it like that? I think that's how you iterate through a stack now. Let's see. If stack.pop is less than start, but the sequence actually starts here. What we're trying to do is find the last valid paren that's after the sequence start, but before the validity part comes in. So how do I describe this one? How to describe that one in the context of the stack. So it's it's not the last one to get pushed. It's not the first one to get pushed. It could be at any arbitrary point. It's definitely way before this one. It could go something like the diff between them. The problem is that it has no information as things are getting pushed onto it. It doesn't know that there's a valid sequence inside of there. I wonder if it suffices again to subtract the size in this case. I think it may. I mean, in this case, before I had that problem because I was dealing with multiple sequences. I think in this case, it may be possible to subtract the size. The problem is I also have to deal with the fact that the start and end indices might be different. I think that might conflate it a little bit. Let's try. So int updated start as start minus stack.size. Okay, and then I do want to add this as a test case as well, because that's obviously even more complicated with a bunch of extra opens. Well, let's replace one of these. I don't know. Let's add that. Yeah, that one seems like it has more opens, so it's going to be more complicated. But yeah, let's try that out. Hopefully that's doable. If. What did I do there? Ah. Too much subtraction. So it doesn't suffice. Ah, because you don't want to subtract. Right, you don't want to subtract these terminating ones. Those don't affect the start. That's interesting. I wonder if I can pop all those off first somehow. I wonder if I can pop off all of the ones that are appended onto the end first. So if I okay, so what would describe the difference between them would be that if there's any index at all between the two. So if there's any space at all between this and that, then they were unnecessary. I can simply remove them. Right? Yeah. Interesting. Yeah, I wonder if I can do that. I wonder if I can just pop off all the trailing left parens and move the end back accordingly. And then the start just peaks to the beginning at that point. So I pop off all the left parens and then look accordingly. So that's not going to work for sure. The size is a dud. Whoa. Size is a dud. Okay, so while stack.peak is not equal to null, and pop equals stack.pop, if stack.peak, the next one, is not equal to null, and stack.peak. Okay, so if to tell if they're appended onto the end rather than appended onto the beginning. I think this is probably the secret that I've been missing the whole time, is how to tell if they're on the end or not. So these guys are on the end because the difference between them is one spot. That must be true of all the ones appended to the end. The ones at the beginning must be considerably far from the end. So like, this one will always be at r.length. Or will it? Or will it? What about the case where there's like a bunch and then like a valence sequence on the end? Let's think of that case. Well, let's see. In this case, it was valid here. This was all valid. And, this was valid too, and this was valid, and then we end up here. Yeah, so in this case, everything was valid, and then all these left parens on the end are there, but they are not actually at the end of the array. So that's actually a valid sequence in the middle there that we need to extract. We need to trim all of these, basically. We need to trim those, and we need to trim those. So we need to trim all the non-matching left parens from the end. Can I read from the right and purge them as I go? Maybe. But then that's going to be even more complicated in the event that there are multiple valid follow-up sequences like this. Extracting that inner valid sequence becomes more difficult. So that's always the case, the difficulty there. It's extracting those inner valid sequences when they're boxed by invalid opening left parens. That's the problem that I keep running back into each time I try to do this. So, last valid paren. I want this one. How do I describe it? Let's think. Yeah, and there's also this case. There's also the case that the longest valid sequence is over there, beyond the left parens. And it's boxed by a valid sequence, and then more left parens. And I still need to extract it somehow. So I thought that my mechanism would find all the valid sequences and then I could just kind of combine them together. But I mean, this would not be discovered, I don't think. Because it would be push, 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 pop, pop. And then it's not empty. And then it's not empty, and then it's push, 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 and then blah, 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 and then we get up to here, and we have a non-empty stack. You actually have multiple valid sequences inside of it. So I'm still not fulfilling the problem because I have multiple valid sequences inside there. So I actually need to extract them from multiple sets of left parens, and that could be any number of them. I mean, it could be multiple valid sequences embedded by non-terminating left parens like this indefinitely. And in this case, I would need to, for my solution, I need to extract all these subsequences. I actually don't, because none of these can be combined, but one of these individually could be the longest. Yeah. So that one individually could be the longest in the entire group, and then I wouldn't pick it up because it wasn't there. Okay. Complicated. Complicated. So there's actually quite a bit of complexity to it beyond the point that I was at. All right. Let's think about this. So, and it's all back to that same problem. Man, this is as far as I got in the first 5 minutes. I'm still there an hour and a half later. Okay. Stack.size greater than 0 is what brings me to one of these situations. So now I know that I'm in the situation where I have any number of unpaired individual left parens that might be interspersed with sequences between them. But I also know that I have valid sequences in between those left parens. So how do I trim out those left parens? You know, at this point I've kind of trimmed out the right ones. I wonder if I can go from the back towards the front and trim out the left ones in the same way. Because I've trimmed out all the right ones like this. I wonder what happens if I work backwards and trim out all the left ones. Hmm. So, I would push right ones onto the stack. Push, 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 push. Hit that. That's a bad one. So then I want, this becomes a sequence. Push, 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 push. That's a bad one. This becomes a sequence. So that's golden. That's fine. The problem with that is that my solution down here expects the sequences to be in order. So now I need to also put them in order. Which fucking sucks. Alright, let's get this back into the state it was in before so that most of it's working. It sucks. This is a lot of work for that last 5% of the problem is like all of the challenge to it. Crazy. I wonder if this is like a 5-line wonder if you know the math behind it too. I wouldn't be surprised if it was. Honestly. Okay, so I'll have to sort them later, but so this is seeking the sequences in reverse. We want to start at r.length minus 1. We want to go till greater than or equal to 0, and we want to do minus minus. So we push right parens, and we pop left parens. Instead, some things are going to be backwards here, so I is now, actually I think I is still the end point, so that should be fine. I'll call these rev sequences. And this would be a single invalid left par. Okay. And then it's I minus 1, I want to say, for the starts instead. Otherwise, I think it's fine. Obviously, they're all going to be out of order, so I'll have to figure out how to sort them. Yeah, that's not right at all. Okay, so logic is poo-poo there. Well, I'll need to start a new stack. I forgot about that. Yep. I think that's all references to stack. Nope. See? Yep. Okay, so I start a new stack. I'll need a new start. So reset start to... what is start in this case? How does this work? If you're going backwards, then you're at the end of the sequence. So in end equals r dot length minus 1. But what do you assume is the start at that point? It's the same, right? start equals end. Yeah. All right. So you assume the end is the same, and then when you pop, the length is I mean you're moving the start up, right? Every time. Yeah, as you go through valid sequences, you find a new valid endpoint. So every time I pop one of these, I move the valid endpoint up. Right? So every time I pop one of these, I move the valid endpoint up. Yep. Okay, I'm starting to get this a little bit. So you're moving the endpoint up, and then end, and then its I is there, and pass end here. I is there, pass end here. End is I minus 1. I think that's closer to it. But it would be, for the length formula, I have end, start is I, have end, start is I, end and start is I want to say that's correct. Guess we'll see. At least this only has to happen if there's leftovers. Oh. Mismatched parenthesis. One more. Okay. Forgot that one. That one right there. Yo. This is very unlikely to work in all cases because, yeah, it's gonna have to. This will work in most cases. But first, I need to put them in order, or it won't work for all cases. Because it'll search through the whole array of stack infos. It'll find the one that's next. But it might have skipped over, while doing that, the next, which it can't do. And that's no bueno. So, now I need to fucking sort my array list of stack infos by start and end point. I've now extracted all the stack infos successfully, but they might not be in order. I got all the ones I could extract in the forward direction in order. Now I need to get the ones, because the ones I extracted in the back direction I appended back to front. And some of those might actually go in between ones that go in the forward direction, so there's no way about it. I need to do a sort. So this would be easy if I remembered the syntax. Dude, I remembered it, sort of. Nice. And then it's stack info A, stack info B. Is it like that? You say stack info 01, stack info 2? I don't really. Comparators, it's so bad. Oh, is it a comparator without? Do you have to type it with carets, maybe? Like that? Is that it? Yeah, okay. Okay, so you type your... Alright. So, it's o1.start less than o minus o2.start, I think. That's going to be ascending order. Well, it either is or it isn't, it's two options. Okay, so let's try it out. It's either that or the other way. Let's try it out. If I don't get it, I'll probably kill myself. Okay, well. I'm so close. Let's see. I've got 229 out of 231 test cases. No, they threw in some kind of wacky curveball in the last couple cases. That is so mean. Leetcode, why? I feel like 229 out of 231 is so good that it's just fine. Okay. So, a mismatch, then a valid sequence, then a valid sequence, then a valid sequence. Okay? And then now seeking the reverses, wrong. A valid sequence, a valid sequence, a valid sequence. Oh, my reverse sequences seem to be starting and ending at the wrong place. Oh, it's just the printout being wrong, I think. Alright. And valid seek starting at 2I, ending at end. Starting at I, ending at end. So it's actually finding duplicates here. The duplicates are kind of, I think, what gets it. Yeah. Because when a duplicate gets sorted, right? When a duplicate gets sorted, it's going to fuck it up. So how do I avoid duplicates? Well, I could change my list into a map. That way duplicates just override one another. I could dedupe my list when I sort it. There might be a dedupe in there already. No dedupe. No dedupe. No dedupe. Alright, well, the slowest and worst way is to do a containment check and see if there's one like it already, unfortunately. Yeah. These are 3 back-to-back, and since they didn't dedupe properly, yeah, it skips the third one. Okay, no, that makes sense. That makes sense, I get it. Alright. I have to search infos for one like it, though. I can't just... Oh, yeah, I'm already using I. If info dot start equal I and info dot end equal end, then no do it. Boolean exists equals false. This sucks. This is going to be such a slowdown because I have to do an O of n existence check every time I add them to my reverse one. But it's not so bad because I've already trimmed most of it going in the forward direction, and it's probably fine. Maybe. I don't know. There's definitely a lot to improve here. This is hardly the worst of my problems. Already exists equals true. If not already exists, then add it. right? That will remove my re-adding the same ones over and over again. Guess I can get rid of this. It's so long. What a solution. What a beautiful solution. What so much of the Java library I ended up using. I ended up with comparators, lists, stacks. It's just a eldritch nightmare of different things. Yep. Well, fuck it. With the print statements and all, I'm 2.5 hours into this. I just want to be done with it. Beat 5%! Ha ha! Champion! Alright. Let's take those print statements out and try again. I will actually not optimize this one because that is way more time than I wanted to spend on this today. But I'm like, I'm like a dog with a bone. I can't give up on these things, I gotta see them through. The print lines usually cost you a lot, so I mean, sure, yeah, whatever. Yeah, the print lines usually cost you a lot in terms of runtime. So this should get me like at least to the 10th percentile. No. It got me to the 29th percentile for memory, though. Less memory usage, so that's neat. Alright, so hindsight, you probably don't need to go forward and reverse the same way. I don't know. I mean, you can probably structure your loop such that you do both at the same time. Maybe you meet in the middle and that cuts down on the runtime. I think you need the list of valid sequences, but I'm sure there's a solution, like algorithmically, mathematically, that doesn't require it. I just wasn't clever enough to think of it. I guess, although I have spent a shitload of time on this today, I'm interested in seeing some lovely Java solutions, because mine is O of 2n, but it also has a bunch of other crap that makes it not. Okay. So, this is pretty much where I was at 5 minutes in. I couldn't figure it out. What is the hidden Jamba Juice that makes it so good? Longest valid perennial. Okay. I mean, this is like basically line for line copy here so far. It's good stuff so far. Balanced case, unbalanced case, yeah. 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 Yep. Okay, so I was alluding to this a few times but never ended up doing it. So the popping off of the left parentheses that are left on the end, the popping off of these orphaned ones that are left on the end of an otherwise valid sequence. So what do you do with them? So start terminal is s.pop. Okay, so that brings you to this one first. And then max length equals math.max end terminal minus start minus 1 end terminal equals start terminal. Alright, here we go. I'll just mark everything so that I can follow the logic. So this starts, that's end. Okay, and then that is start. Okay. And then the max length is 0. Okay. So start terminal is that. Max length becomes end minus start, which is the difference between these, which is nonsensical. But I guess it's the length of this one. And then end terminal becomes start terminal. Okay, so we move up here, if I'm correct. Yeah, and the next generation will be here. Okay, and then we'll go here. And then the next generation will be here. Oh, wow, that does work. That reads that valid internal sequence. So we're capturing the space between non-matching left parens and also including the space from the end to the first non-matching left paren. Well, brilliant, certainly, but not something that any reasonable schmuck could think of in the span of 30 minutes. But actually, very close to my very first solution that I got like 15 minutes in. But of course, no points for being very close. Actually, considerable points for being very close. It probably would have been enough to just stop there. In a real interview setting, I think most people would have accepted my first solution, and this one probably would have gotten me less credit. Any others that are? Same thing, basically. Yeah. Okay. Makes sense. But would not have figured that out. Definitely wouldn't have figured. But now that I see it, it makes sense. Yeah. I was confused about the end case, but yeah, length minus the first terminating left paren that's bad covers that, obviously. And then otherwise, the length between mismatching left parens that you find the max of the length between mismatching left parens always gives you the longest sequence internally. Yeah, that's a given because between those two, you had a valid sequence. So that's fine. Yeah, very clever. All right, gang. Nobody stayed tuned for this, I can guarantee it. But if you did, thank you. See you next time.